What up, dudes? What up, algebra dudes? Let's do this. Let's do this problem. Sound good? All right. So check it out. Chapter 6. I'm pretty much not teaching you anything new. In fact, Chapter 6 is called Putting It All Together, and if you feel like you've really got the chapters 1, 2, 3, and 4, 5 down, then 6 is really just, putting all of the skills together. But I feel like we kind of already did that in Chapter 5. But here's what Chapter 6 is all about. I'll show you. I'm going to make up a few functions. Let's go with h of x, and it equals x squared minus x minus 2. And we'll go with g of x equals x cubed minus 4x. All right. Let's do everything we can with this function. Sound good? So, before I even get started on this sucker, I feel like the first thing I should do, before I even get started, is factor this down as much as I can. The h of x, right? So, that's pretty straightforward. That's that old game. We've done it before. X. Let's see. What two numbers should I put over here? Here and here. It needs to end up being negative 2 as multiplying it out, and you need to add it together to be negative 1. Nothing. Actually, you know what? I'm sorry. I'm going to change this problem right here. I'm going to make it x squared plus 4. X squared minus 4. All right. Nothing? Really? Nothing works? No, something works to go over here, this number over here, and this number over here. Isn't it like negative, no, positive, no, negative 2 and positive 1? Yeah, negative 2 and positive 1, right? Because x squared, negative 1, you add up the 1 and the negative 2 to make negative 1. You multiply the 1 and the negative 2 to make negative 2. This isn't new stuff, right? This is like old school stuff. All right, what's going on, Fia? All I did was I said, hey, guess what? In Chapter 6, you're learning nothing new. Chapter 6 is all about taking all of your skills that we've learned in the previous stuff and just putting it all together. So basically, I threw out two functions. I said h of x squared, or h of x is equal to x squared minus x minus 2, and g of x is equal to x squared minus 4. And all I did was I just, sure, I can make my camera bigger. Hey, I'll show you how to make the camera bigger. You ready? Go into the bottom right-hand corner. Do you know where it says default view or default mode or whatever? Okay, fine. I'll make the camera bigger. All right. On the bottom right-hand corner of your webcam meeting, it says default layout. You click on that drop-down menu and you can click to webcam. But I can also force your screens to look like mine. All right, anyway. So all I did was I took this function and I did the, if I took this function, I factored it down. Cool? And then what about this one? I'm going to take this function and I'm going to factor it down. So that one's pretty easy. Do you guys know this one? X squared minus 4. There we go. X plus 2, x minus 2. Because you recognize that there's a difference in squares. As what I mean by that is there is a, this is a perfect square and this is a perfect square, making a difference of square formula that you can use. There's no such thing as the addition of perfect squares, but there is such thing as a difference of perfect squares. Does that make sense? All right. So if I were to ask you to find the x-intercepts of h of x, can you tell me that right off the bat? Positive 2, and negative 1. Perfect. If I were to find the x-intercepts of g of x, what are they? Negative 2 and positive 2. Perfect. Right there and right there. So what I'm saying here is you guys are getting really good at this stuff. Like, let's go back to parabolas. If I were to graph that, that would be graphing at positive 2 and negative 1. It would be a regular parabola going opening upwards. We know it's opening upwards because we can look at this number over here and say, hey, that's a positive number. That means it opens upwards. Does this all make sense to you? Nothing new. Nothing new. Okay, let's see. Yeah, it's all pretty simple. Oh, okay, here. What if I were to graph, so that was the graph for h of x. What if I were to graph 1 over h of x? And yes, Sophia, we can go over all the homework that I messed up later, after this. What if I were to graph 1 over this equation? The inverse of this. Okay. Well, then those there we go. This is exactly what I was just about to say. Those x-intercepts, which were at 2 and negative 1, aren't x-intercepts anymore. They actually became your vertical asymptotes. Because at these x-intercepts, that's where h of x equals 0. And the problem is, when you have it in the denominator, those zeros are a big problem in the denominator, right? So we kind of do a dot, 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 and a dot, 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 dot here. Now, what is my x-intercept if this is the function I want to graph? Zero? Nope. Bounces? Nope. It doesn't exist. Yeah. Remember, what you do is you set this thing equal to 0 for your x-intercepts, of course, right? You set the whole dang thing equal to 0. Well, in that case, I can just say, I'm going to multiply h of x up there, so I have 0 equals to 1. Does 0 ever equal 1? No, 0 never equals 1, so therefore there are no x-intercepts in this particular case. All right, and then if I were to go, how's about, if I were to go, what is my, so there's no x-intercept, so I'm not going to put any dots on this line. What is my y-intercept? Well, the actual function that you wanted me to graph was this, right? And to find the y-intercept, I just take x and I make it 0. So that would be 1 over 1 times negative 2. So negative 1/2. All right, so at negative 1/2, right about here, that's the y-intercept. All right, my friends, how would you graph this thing? I think we have all the pieces to graph it. Oh, I'm sorry, I forgot to ask. What is the horizontal asymptote? The horizontal asymptote of this graph is 0, obviously, because the degree of the denominator is bigger than the degree of the numerator. All right, now we're graphing it. So I'm going to start off right here. Am I going to go up or down as I go to the right-hand side? I'm going to go down, exactly. All right. You're exactly correct, Sophia. Why? Come on, somebody else ask me why. Ah, there we go. What Sophia is saying is, I can't go up. I can't, as I go to the left or the right, starting from this y-intercept, I can't go up. Because if I went up, I would have had to cross the x-axis. Does that make sense? And I'm not allowed to cross the x-axis anywhere. So obviously, as this thing gets closer to this asymptote, it goes down. Now, these being pretty straightforward, standard first-degree asymptotes, see, there's a 1 and a 1 right there that you guys can't see, then this thing goes from going down into, negative infinity, and then starts up here in heaven, way up here, and we know that it goes towards the 0. Pretty cool? And then, of course, on this side, as we do that, we kind of do that crazy asteroid game thing where we go off the screen over here and we reappear right over here. And then as it goes further, it goes out to 0. Are we cool with that? And in this case, there isn't any x-intercepts. Look, I've never crossed the x-axis anywhere in this graph. So, in this RAT3 homework, where I give you something like this, just this straight, and I ask you, what does the end behavior look like? And I gave you a bunch of those graphs. And you guys couldn't tell me, well, why is it? And actually, the answer to this particular one would be this. And then you guys say, why is it this and not this? Is that, that kind of stuff? That's the kind of questions you guys ask me. And you say, wait a second, I'm looking at this thing, and all I can tell is that the horizontal asymptote is 0 because the degree of the polynomial on the bottom is bigger than the degree of the polynomial on top. Right? Am I making sense here? I'm talking about your problems with RAT3. Okay. And what I told you back in RAT3 is I said, wow, I really sucked at giving you guys the homework. What I should have just asked you is, what is the horizontal asymptote? Because with your knowledge, you can't figure out whether or not the graph is either this or the correct one is actually that one. Unless you graph it on Desmos, right? But now you can, actually. After you've graphed it, after you've made something like this, you realize it does look like that because of the horizontal asymptote, or of the two vertical asymptotes. In fact, I actually take that back. Maybe I wasn't such an idiot. Maybe I did it correctly the first time. Let's look at something real quick, all right? I asked you to graph this. That's the same thing. I just foiled out the bottom. Cool? And back in RAT3, I taught you guys how to do horizontal asymptotes. I said, look at the degree of the numerator, look at the degree of the denominator. The degree of the numerator, the only relevant number is 1. The degree of the denominator, the only relevant number is x squared. Right? I want you to go into Desmos and graph 1 over x squared. I bet you I'll tell you what it looks like. I bet you I know. Because I'm so smart. It looks like this. So you know what? I take it back. I did ask you the question correctly. Haha. But it's all right. I still went back and gave you guys full credit for only getting half of them right and all that kind of stuff. Because I'm a nice guy, but I'm just saying. I understand that it was a little bit tough to get there. But I think that after you is what I said true? Where you just got to practice this thing a whole bunch of times, do a whole bunch of problems, and eventually you'll get it. And I can tell you till I'm blue in the face all these tricks, but you just got to do the homework. We cool? So I think, what if I asked you to do this? What if I asked you to graph, all right, let's let f of x equal to g of x divided by h of x. Are we cool with that? All right. Well, all you got to do is plug in g of x, which is x squared minus 4, over h of x, which is x squared minus x minus 2. And then we got to go through factoring it. Oh, but guess what? We already factored it. That's equal to x plus 2 divided by x minus 2 all over, or times x minus 2, x plus 1 times x minus 2. We cool? All right. You're right, Lucas. The horizontal asymptote of this particular function of f of x, which is actually g of x divided by h of x, is 1. You're absolutely correct. My question is, what are your vertical asymptotes? Let's ask that. Sophia says it would be positive 2. I disagree with positive 2 and negative 2. I disagree. Look at this. Negative 1 and positive 2. I still disagree. You guys are thinking, what? I disagree. It's wrong. You're half right. Nope. Bradley, you just said the same thing, which I already told you was wrong. I'll tell you what the vertical asymptote is. You ready? There's only one of them. Nope, there's only one of them. Lucas, what did you miss? Ah, there we go. Yeah, oh, yeah. See, before I go through all of this graphing stuff, let's cancel this stuff out. Let's simplify our lives here. Because I'll tell you what, this is easier to graph than what I had before. And if it canceled out on top and it canceled out on the bottom, then boom, you're done. Does that make sense? We don't need to consider that crap anymore. All right. Vertical asymptote at negative 1. I agree. Well, I agree with me because I actually was the one who told you that answer. Where is the, what was the next thing we look for? The x-intercept. Yeah, that's right. I actually remember what we look for. I just want to. Oh, negative 2. Okay, so right here. Where is the y-intercept? The y-intercept is at positive 2. Okay, cool. Up here. We cool? All right, my friends. Oh, and horizontal asymptote, right. Lucas actually said that earlier. The horizontal asymptote is 1. Do you guys have a feel for how this graph looks? Well, I usually start off at the y-intercept when I draw my graphs. And I'm going to go to the left, towards the vertical asymptote, okay? Am I going to go up or down as I start from my y-intercept and go to the left? I'm going to go up. Very good. Yes, because there are no y-intercepts between here and here. If there was a y-intercept, like right here, then I think I would probably hit this and go down. That's what my thoughts are. Does that make sense? Wait. All right. I've got the graph exactly how it is. Why does it look like how it is? Well, I started at the I started at the y-intercept, and Sophia's actually absolutely right. I'm going towards this vertical asymptote, and as I get closer to this vertical asymptote, I have to go up, not down. The reason being is because I can only cross the x-axis here. I can't cross it here. Does that make sense? Okay, fine. Yes, Lucas, maybe it would be possible. Maybe I could go down this way. But I better not touch the x-axis, so kind of go like this. All right, Lucas, what is it that you're saying? Why doesn't? Oh, no. I just drew part of it. Let me finish drawing the rest of it. Yeah. All right. So I drew this half of this side, right? Now I still got to draw this half of this side, and I know that as I go further out to the right, it's going to look like this dotted line. So I would venture to say that it pretty much simply looks like that. Are we cool? Yeah, it gets closer to the horizontal axis. Now, could it, and I know it doesn't look like this, but could it look like this? I'm just wondering. Could it go like this? Yeah, you're right. Lucas, it could look like that. Because even though it goes down and dips across the horizontal asymptote, you're still allowed to, that's fine. As long as you go further to the right, as you go off to infinity, it goes towards the horizontal asymptote. You're right, Bradley. I definitely don't think it does. It doesn't, this thing definitely doesn't display any weird behaviors when I look at this graph right here. So I'm pretty sure that it just stays right above it and it just gets closer and closer to there. Now, as I cross this vertical asymptote, I know that this thing comes in from the bottom. And then I'll probably look something like that. We cool? That's a pretty cool one. Yeah, that's it. That's all I wanted to teach you. We're done. Haha, we're done fast. That was early. That was quick. Here, I'll leave that up there. Why don't we go over? I have an essay to write. All right. Well, yeah, go for it. Here's what I'm going to say: is you're allowed to leave. However, if you have any questions, you should stay. But I think that we explained everything that we need to. Chapter 4 was not, or chapter 5 was, or 6 was not necessarily hard. It's easy. Yeah. All right. Sophia, you had some questions that you wanted me to check out. So it looks like I just screwed up in that. Let me fix those things, those problems. Yeah, sometimes those things happen. Why don't we take a look at chapter 4, and you can tell me exactly which ones you wanted me to take a look at. All right, I'm going to stop the recording though.